Welcome to NEMCtv6, the Focus program. My name is Terry Kozlarich, your host, and with me today is Richard Pollman, Rich, from the National Weather Service, and we're here in White Lake Township, and we're going to learn a little bit about meteorology and weather today. So how you doing?
Well, we're doing very good at the Weather Service. Thank you for coming out, and happy to talk all about the weather.
Can you tell me a little bit about how long you've been a meteorologist and maybe how you got interested in it?
Yeah, I've been a meteorologist for 20 years. So I graduated out of college and went right into the National Weather Service. What really got me interested in weather was when I was 3 years old, my house was hit by a weak tornado.
Okay.
And I remember looking out in my backyard, seeing the power lines hit our one and only tree that we had in our yard, and the tree was on fire. And it was my mom that saw the tornado as it was moving across our backyard and into the woods behind our house. So that's really what got me interested in weather. And really, ever since 3 years old, I've been studying the weather one way or another.
And have you always been here at the White Lake facility?
I haven't been always here. I've been in Southeast Michigan all my life, except for 3 years when a weather service career took me to Knoxville, Tennessee, which was really interesting to learn about the weather in a different area of the country. But otherwise, it's all been in Southeast Michigan and here at the White Lake office.
So what do you find as maybe the differences between Southeast Michigan and Tennessee?
The big difference with Michigan weather is that we have the Great Lakes, and they modify the weather. In Tennessee, we have the mountains that modify the weather, but the nice thing about the mountains, they're always the same height, they're always the same shape, whereas the Great Lakes change, their water temperature changes, and that affects the weather. So during the wintertime, the water is warm, leads to our lake effect snows. In the summertime, the water is relatively cooler than the land, and that leads to a whole different set of weather forecasting issues.
So is White Lake Township the only one for Michigan, or is it just for a specific area?
Well, we do focus on Southeast Michigan here at our White Lake office, from the tip of the thumb down to the Ohio border. We also have responsibility for Lake Huron, Lake St. Clair, and the Michigan waters of Lake Erie, but we do have other offices across the state and across the country. So in Michigan, it's going to be the Grand Rapids office for Southwest Lower Michigan, Gaylord for Northern Lower Michigan, and then Marquette for the UP.
Okay, and so how do these different areas work together to, like, all of Michigan and give weather alerts and things? How does that work?
Well, we will issue the forecast and warning specifically for Southeast Michigan, but obviously the weather is going to be coming from Grand Rapids, so we're in constant communication with the National Weather Service office in Grand Rapids through our local instant messaging that we have through our local computer systems. And we can always call them on the phone and see what's going on. So we are always coordinating with the surrounding office to make sure we have a consistent forecast for all of the state.
Okay, so what are some of the daily tasks that you do? I mean, are there daily, weekly, monthly?
It's pretty much a daily and even a shift-by-shift task. We start with observing the weather.
Okay.
We'll see what the high and low temperature was today. We'll send up the weather balloon 2 times a day at our office to measure the temperature in the higher levels of the atmosphere. The radar is an observational set. And then we'll forecast the weather. So we always have a short-term forecaster looking at the next 24 hours when the rapid changes are happening. And then there's a long-term forecaster that's working on days 2 through 7. And that forecast is issued by 4 a.m. and 4 p.m. each day.
Okay. You said you send up a weather balloon every day?
We do. We send up a weather balloon. It's not like...
I see that you got something sitting over there. Would you like to show me?
Yes. This right here is a weather instrument that goes up with the weather balloon. There's a piece of string that is attached to this weather instrument.
Okay.
And the balloon is made out of a neoprene type of material that can really stretch. And when we fill it up with our hydrogen gas, it gets to be about 3 feet in diameter. So it's a little bit bigger than what kind of balloon you might get at a restaurant or for a party. And when we let the balloon go with the hydrogen gas, it just rises through the atmosphere. We don't get it back. And we want that to happen, unlike if our kids get the balloon and it goes off in the air, they're not going to get it back. And the things that we measure off of this right here is the thermometer that's measuring the temperature. Okay. There's a little humidity sensor in here that's measuring the relative. Yeah, it's measuring the relative humidity or the amount of moisture. There's a barometer to measure the pressure on the inside. And then we use math, and the computer uses math to figure out the wind speed and direction using a lot of trigonometry.
So is this stuff sends information back to the computers?
It does, with a radio signal and a GPS signal.
Okay.
So we get data back 2 different ways with a little bit of modern technology with the GPS. And all this data helps us with the forecast of severe thunderstorms in the next 6 hours. It will also goes into a supercomputer where we can use that for a computer model. In Washington, D.C. and in our local office, we're running computer models to simulate the weather for the next 2 days all the way to the next 10 to 17 days to get a forecast. And the base of that is the weather data that we collect from this weather instrument as it goes up. We need to know what's going on at 30,000 feet to forecast what's going to happen down here on the ground.
Does this go that high?
It actually goes up to 100,000 feet, which is about 3 times higher than jet airliners flying.
Okay.
And eventually the balloon expands as it gets up there. There's less air pressure and the hydrogen gas takes up more space and it expands. And it gets to the size of a very big backyard shed or a very, very tiny house, something on that size, and then it expands one more time and it pops and it falls back down to the ground.
And where does it go? Does it come back home?
It does come back to the ground. It doesn't come back to our office. What happens is we have a parachute. It's really kind of like a big toy parachute, plastic, that just expands out, maybe about this big. And as it gently glides back down to the ground, most of the time our winds are 50 to 100 miles an hour up there in the upper levels of the atmosphere. So these instruments end up as far away as 200 to 300 miles away.
Wow.
So most of ours end up in Canada, northern Ohio, or in the Great Lakes themselves. And if anyone ever finds one, and in southeast Michigan, you may find one of ours in the summertime when there's less wind, or you may find one from the Green Bay, Wisconsin office during the wintertime when there's more wind in the atmosphere. And if you ever find one, there's instructions on here of what to do. Tells you that's a harmless weather instrument. You don't have to worry about it.
Right, I see that. It says right here in big red warning.
Yeah, big red warning.
So you don't have to worry about it ticking or anything.
Right, exactly. We don't want people to get confused about what that is. And then you can send it back to the Weather Service, to our recycling center, and we will recondition them and use them again. Only about 20% across the country are found and recycled. Some are kept as souvenirs, which is fine. Others are just never found. There's a lot of open space across our country, and so a lot of them are just not found. But 20% do get sent back to our recycling center where we can use them again.
So did you ever have any strange things with people finding them, maybe thinking it was something else?
When I first started in the Weather Service and I was launching these balloons in Flint, we did have one story where somebody found it in a tree and thought it was a bomb. They called the police out. The police obviously went out there and realized right away that wasn't a bomb in their tree.
Is that what maybe got them to start marking it, huh?
Yeah, probably a number of those type of stories across the entire country probably led to some of those markings, yes.
Wow, these are pretty interesting stories. So, can you tell me, when did we start first recording weather?
In southeast Michigan, we started recording weather about 1850. Officially, our records for Detroit started in 1874.
Okay.
And across the country, the first weather recordings were way back in the mid-1700s. Benjamin Franklin is probably the most well-known weather observer back around the start of our country recording the weather.
So, I mean, today we have electronics and it's real easy to share. Was it just more of a regional thing that people would do, or was it something that they would share with other areas?
It was regional to start with, but very quickly the United States government in its infancy realized the importance of sharing that information. And as technology improved in the 1800s with the telegraph, things became easier to share. But yeah, in 1874, Detroit, we have some of the books behind us, have some of the original 1874 recordings.
Wow.
And you can see the penmanship that they were using. It was terrific penmanship, and it's still on paper, and you can still see the original observation that they took. And that was shared across the country through the modern technology of the 1800s at that time. So
tell me why the United States uses Fahrenheit and the rest of the world seems to use Celsius.
I think that's just the Americans being our individualistic selves. Celsius is easier in the fact that freezing's at 0 and boiling water's at 100 degrees Celsius. In our weather business, we use Fahrenheit at the surface, and I still have a little trouble converting from Fahrenheit to Celsius. But as soon as I get 50 feet off the ground, everything we do is in metric systems. And I would have trouble telling you the temperature at 1,000 feet above the ground, what is average in Fahrenheit. I can tell you that in Celsius.
Because the data all comes back to you in Celsius?
It all comes back to us in Celsius, and that's the only way that we use data above the surface. Everything is in a metric system in the National Weather Service, except down on the ground. Whenever we report weather down on the ground, it is always in the English units, Fahrenheit and feet.
Okay. Well, we're going to take a break here for a minute, and we'll be right back.
Son, tell him that I've begun to dream of things to come, and tell the trees not to look for me. I'm going to find some peace of mind. Wake the sun. Wake the sun, wake the sun, wake the sun.
Welcome back to NEMCtv6, the Focus program. My name is Terry Kozlarich, your host. I'm here with Rich Pollman from the National Weather Service. Welcome back.
Well, thank you.
So tell me a little bit about clouds.
Well, clouds are going to be important to tell us what sort of weather is moving into the region, and especially going to be important for storm spotters.
Okay.
Some of the clouds that we're going to be looking at are thunderstorm clouds and the clouds associated with thunderstorms, whether it's a shelf cloud that might tell us one thing, and then the clouds that are there during tornado development. Those are also pretty important features to look at.
How many different types of clouds are there? I mean, I like the big fluffy ones myself, or when there's none at all so I can get some sun.
Yeah, there's generally about 30 different types of clouds out there. And we do categorize them in 4 main categories. We have our low clouds, which are stratus clouds. Then we have our mid clouds, which are labeled alto stratus, alto cumulus. And then we have our cirrus clouds, which are the very high wispy clouds. And there's 9 different types of those. The 4th type are the clouds that have vertical development to it. And those are the thunderstorm clouds, the puffy clouds that you like to watch.
The ones that you have to watch, right?
Those are the ones we have to watch during those certain days.
Well, I'd like to take a moment here and take a look at some of those different types of clouds. Maybe you can explain to me what is what. I mean, when I look up there, I see puppy dogs and kittens and different things, and people are laying back, but I'm sure you see much different.
Yeah. In those cloud features, we look for the different types of thunderstorm types with those clouds. The single cell storms that we see on the image here, the multicellular cloud, thunderstorm clouds, the squall lines, and then the supercells, which are the most dangerous thunderstorms. So we look at the different types of thunderstorm clouds to help us determine what severe weather is moving into the region.
Okay, well, let's take a look at some of those clouds. Okay, so this is a supercell. What is a supercell?
Well, a supercell is the most dangerous type of thunderstorm. What happens is the entire thunderstorm is rotating.
All right.
And that leads to a much stronger storm. And these are the ones that are going to produce our tornadoes, the large hail that are golf ball to baseball size hail. And then it can also produce winds up to 100 miles an hour. And some of the features that we're going to look for is this large individual cell. It may be 5 to 25 miles in diameter, so sometimes you can actually see the entire thunderstorm as it moves towards you. Other times you're just going to see certain features of the storm because it may be large enough. But one of the key things when you're about 20 to 40 miles away from the storm is you're going to see the very top of the thunderstorm, and it's going to have a large canopy of cirrus clouds up there, and above that canopy of cirrus is going to be this overshooting top that's labeled on the diagram.
Oh, the big puffy part at the top.
And the big puffy part at the top, and that's a trait that there's a severe thunderstorm moving towards your area.
Okay.
And so as that storm's 20 to 40 miles away, you're going to want to listen for any warnings. You're going to keep an eye on that storm as it heads towards you. Then some of the lower cloud features that are on here are the what we call the shelf cloud, which is the first low clouds that you're going to see when the thunderstorm moves in. Again, you have all that higher cloud, the puffy top, And then as the storm continues to move towards you, the first low cloud feature is a shelf cloud, and that's the location where you're going to have the strongest winds. And so you've got to watch the leading edge of the thunderstorm for the wind potential.
So those are the ones that are like turning dark. I mean, I look here and I see all these white clouds, and I don't think of storms unless I see them starting to get dark.
And that's usually what's going to happen. They're going to be white in the distance because the sun's going to reflect off of the cloud. But as the storm moves closer to you, the sun is being blocked, and it becomes that very dark cloud that we're used to seeing as the storm moves in. And again, the first low cloud feature that you're going to see marks the leading edge of the storm, and that's when it's going to be time, if there's a warning out there, to make sure you're inside in a nice shelter to shield yourself from any wind. That's going to be the first thing that hits in any thunderstorm.
Okay, so how do you get some of your warnings? I mean, I hear about Doppler radar. What is the difference between Doppler radar and regular radar?
The main difference with the Doppler radar is we can look inside the storm and see the motions inside of the storm. Doppler radar allows us to see motion toward the radar and away from the radar. And if a storm is rotating, part of that storm is rotating towards the radar, directly at it, and another part of the rotation is rotating away from the radar, directly away from the radar. And it allows us to see the rotation inside the thunderstorm.
So that's the newest now. What did you used to use?
Well, the old radar just told us where the storm was at and how heavy the rain was falling in that location. And it just gave us an indication of that. Occasionally we would be able to see some hail signatures in that radar data, and we can still see that with the Doppler radar, and even more detail in the Doppler radar. So we can see where the storm's at, how heavy the rainfall is, some hail signatures, and the Doppler part of the radar allows us to see the rotation. As that rotation gets lower to the ground, gets tighter, and spins faster, we obviously get concerned about tornadoes. And that's why we can issue a tornado warning about 15 minutes before the tornado touches down. And that's a national average.
So you have the other weather stations in Michigan that maybe give you information. Is that the only place you get your information from? Radar?
We get our information from Doppler radar, from our satellites, from all our observational equipment. We have observation sites out there at the airports, and we have a lot of spotters out there that give us information of how much snow is falling, what the severe thunderstorm is producing as far as wind, hail, or tornado. And so we use all that information to piece together the weather story to issue the forecast and the warnings.
So when you say spotters, I know that it's been pretty much romanticized in movies and everything of people out there chasing storms and sending balloons off. Is it actually that way? I mean, do you have people running around?
We don't have anyone that would be classified as a storm chaser in Southeast Michigan. All of our spotters are pretty much at their home, at their place of business. There are a few that are out there that may chase, but in general we don't suggest that in Michigan.
Nothing you recommend?
In Michigan we just have too many hills and trees to see anything. A lot of traffic that you're going to get caught up in. And there's a lot of fog and haze with our thunderstorms, so we don't have the visibility like you do in Kansas and Nebraska, where you can just see across the flat plain forever.
Yeah, that makes a lot of sense. So I heard once when I was a kid, if you count, 100, 100 between the thunder and the lightning, you can tell how far away a storm is. Is that true?
That is true. For every 5 seconds, that's how far away the lightning hit. And the reason for that is you see the lightning bolt, and the speed of light is much faster than the speed of sound. And the lightning creates the thunder. It heats up the air so fast it creates a sonic boom. And the expansion of the air.
And that's what the thunder is, a sonic boom?
It's a sonic boom. Because the air is being heated up by the lightning so fast that the air expands and it creates the sonic boom. And it takes 5 seconds for that sound to travel 1 mile. So you see the flash of lightning, which is instantaneous, and then for every 5 seconds, that's 1 mile. And it's going to be very rare that you're going to hear thunder beyond 6 miles. It does get dampened out by the trees and the buildings, and so it'd be rare that you would see the flash of lightning and then count 40 seconds. That would be an exception.
Okay. So when I'm looking at the radar on TV and I see the red, the yellow, and the green, tell me a little bit about what all that means.
Well, if you see that on a weather map, if it's talking about the watches and the warnings, generally speaking, we like to, and we do see tornado warnings are labeled red, severe thunderstorms are labeled yellow, and a lot of our flood warnings are labeled green. So if you go to our website, look at a lot of the television stations, that's what those are going to mean. On the radar themselves, if you see the red and green together, that's the Doppler radar that they're depicting.
Okay.
And we're trying to show you the rotation. If you're looking on our website, and again on TV, you can see that. On the regular radar, when you're looking at storms moving in and you see those greens and yellows and then reds, we're just showing you the intensity. And most of the radar depictions are pretty similar, where they're showing green is the light rainfall or light snowfall. The yellows gets more intense, and certainly the reds and purples indicate the heaviest rain and probably some hail mixing in with the rain.
So is it true that most storms move from the southwest to the northeast?
It is true. Generally, our weather does move in a west to east direction. And most of our severe thunderstorms are going to move in that direction as well. Southwest is probably more common than any other westerly direction, whether it's due west or from the northwest. We have had severe thunderstorms, though, move just about any direction. We've had them move directly from the north, directly from the south, and every once in a great while you might actually get a thunderstorm moving in from the east. But that really is an exception.
So tell me a little bit about lake effect. I mean, I've been along the lake. Obviously, you get more snow over there, so it seems. And what causes that?
What causes lake effect is that the water is much warmer than the air.
Okay.
And the air and the land will interact with this warm water. And you always are having, weather is governed by the transfer of energy, which is the temperature difference in the atmosphere. So when you have this warm body of water, it wants to get colder because the cold air that's moving over, and all this warm air rises into the atmosphere. And as it rises, it creates, just like over land when we have rising air, it creates clouds. And if you get enough of it, the clouds will start to rain or snow. And so basically it is the colder air over the warm waters. And all that warm energy from the lakes gets lifted up into the sky with the cold air coming over it. Enough of it, if there's enough of it, it will lead to snow in the western portion of Michigan. And every once in a while that snow can move its way all the way east to Metro Detroit. And every once in a while we also get it off of Lake Huron. If we get a northeast wind, it can make it all the way down into Macomb County off of Lake Huron.
I think we saw some of that just a few days ago.
Yeah, and that has happened this year, and it usually happens once or twice a year where we can get that lake effect snow off of Lake Huron.
So I've been down to Florida and been chased out by a tornado, but I've never heard of a hurricane in Michigan. Why is it that they can have tornadoes, but we don't seem to get hurricanes? What's the difference?
Well, for a hurricane, you need a body of water that's large enough to support a large low-pressure circulation. And that body of water needs to be 80 degrees.
Okay.
And so while we have the Great Lakes, and a hurricane is roughly the size of one of our individual Great Lakes, it would really be tough to have that hurricane form over that body of water because, again, a hurricane's about that same size, so you need a little bit more water than the Great Lakes. In addition, only Lake Erie really gets up to about 80 degrees on the hottest of summers. Lake Huron, Lake Michigan, and Lake Superior all are going to be well below 80 degrees, so you don't have that tropical air mass. So that, in combination with the fact that what really causes hurricanes are storm systems in the tropics. They're moving from off the coast of Africa, across the Atlantic Ocean towards the United States. Some of them hit the United States, others curve into the Atlantic Ocean harmlessly away from the United States.
Thankfully.
Yeah, thankfully. So we don't really have any of those tropical waves that are moving through the Great Lakes that could even spawn a hurricane. So it's really those three reasons. The warm water we don't have, we're not big enough in the Great Lakes, and we don't have any tropical waves that are the starting point for the hurricane.
And so which ones are considered more dangerous, hurricanes or tornadoes?
Well, it's going to depend
on whether you've gotten hit by one.
Right, exactly. A tornado is going to be the most violent windstorm, but most tornadoes are a quarter to a half mile wide when they're the most extreme, and may only be on the ground for a couple of miles. Some of the more extreme tornadoes that may be a half mile wide, they're going to be on the ground for 20 to 50 miles. That's still not a very large footprint, but if you're in that path, it is a very destructive storm. Hurricanes, the most extreme hurricanes might get up to 150 miles an hour right around the eye wall or the center of the storm. But there are some hurricanes that can be 300 miles across. So it's going to affect more people, but it's not going to be as extreme as the tornado. So it depends on how you want to look at it. If you look at aerial coverage, a hurricane is far worse. But if you look at discrete damage along the path, a tornado is going to cause more destruction right at its path.
And probably a little less warning for tornadoes too.
And that's a big issue. Yeah, a hurricane you can see form over the Atlantic Ocean. We have the satellites that help us with that and the computer models. And so you can have days of warning for a hurricane where our best for a tornado might be 15 to 20 minutes of lead time for a tornado.
So is it true that animals can predict the weather?
Well, they have some predictive capabilities. Mostly they can sense when the moisture is increasing or decreasing, and they can sense when the pressure is changing. And so we could have a low pressure system moving in, and they can tell that the low pressure is coming, and they have a sense of that.
What do they do that people actually look at it and can?
But I think it's just their behavior and how they may move about or take shelter or whatever the case may be. The difference is we can have a low pressure coming in and in our weather business we're going to be able to see if that low pressure is going to have a little bit of rain, a lot of rain, a line of severe thunderstorms with it, if it's going to have a lot of wind or a little wind. There's a lot of different weather elements that happen around a low pressure, and each storm system is going to be different. Whereas out there in nature, they're just really sensing the change in the pressure and the change in the moisture without really knowing the details.
They don't know what's coming, they just know it's changing.
You're right, exactly.
Well, we're going to take a break here for a moment, and we'll be right back.
You're on your way to meet up with friends, but you can't seem to get anywhere quickly. You don't want your friends to be annoyed, so you text. You're on your way. Five seconds is the average time your eyes are off the road while texting while driving. Make sure you get where you're going.
Welcome back to the Focus program. I'm Terry Kuslarich, your host, with Rich Pollman from the National Weather Service. So tell me a little bit about the storm spotters that you use and how people can get involved in that.
Yeah, the spotters are very important. The radar will see into the clouds and the cloud base, so we can see the hail in the storm, we can see the wind in the storm, we can see the rotation at the cloud base. But what's happening below the cloud base, we need the spotters to tell us that. And it's a part of the warning system. We look at the environment, we look at the radar, and we look at the storm spotters. And basically, if 2 out of the 3 are telling us to warn, we're going to issue the warning. So they're a key element in that. And so we do offer spotter training all across southeast Michigan through the spring months from about the end of February to middle of May. We'll be coming out to Macomb County. And there'll be 3 training classes in the month of April in Macomb County. And then there are training classes in surrounding areas as well, and everybody's welcome to attend the training, learn how to spot, and learn a little bit about weather safety.
Okay, so what is some of the stuff that they will learn during that time?
What we teach them is how to report, what exactly we need you to report, and some of the cloud features that will help you, knowing what the shelf cloud really looks like and what that tells you, the wall cloud and the development of a tornado. The different thunderstorm types and what that means. And so the spotter will learn all that. It's about an hour to hour and a half class, one-time training, and you are ready to report to the National Weather Service.
So do you need spotters out in Northeast Macomb?
We need spotters all the time. We have great attendance and great spotters. We have about 5,000 spotters across southeast Michigan, which sounds like a lot, and it is great that we have that many, but we can always use more. Think about how big southeast Michigan is and how localized these storms can be. A tornado may only be a quarter-mile wide and 3 miles on the ground. A wind path, damage path might only be 5 miles long. And so to get those reports, we do need a lot of spotters. We have 6 million people in southeast Michigan that we warn for, and about 5,000 of those are spotters, so we can always use more.
Well, thank you very much for giving us this information, and thank you for coming.
Well, thank you. I'm glad to talk about the weather, and we really look forward to seeing everybody out at a spotter training class.
If you're looking for more information on spotter training, stay put, because we're going to run some information for you. Thank you for watching.